Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Calorimetry, that too part B. If you are watching this video without watching the concept video, then this will be very difficult for you. So watch the concept video first, then this video. After that we are going to solve all the numericals. All these videos will be available in the description box. So now without wasting any time, we'll start with our first question. For all these questions, we know the answer. Why? Because we have watched the concept video. Then why we have to watch this video? We have the knowledge, but we don't know what kind of questions that will come, and we don't know how to tackle it. So that is what we are going to learn from this part. Our first question, write down the approximate range of temperature at which water boils in pressure cooker. We know what is the boiling point of water, that is nothing but 100 degrees Celsius, but that is not they are asking. They are asking what temperature, at what temperature the water boils in a pressure cooker. In pressure cooker, we know the pressure will be huge. That's why the temperature of boiling water will be 120 degree to Celsius to 125 degree Celsius. So this is the temperature at which water boils in a pressure cooker. Our next question, complete the sentences. See, there are 6 different questions. We'll solve one by one. Okay, first we'll go for A. When ice melts, its volume decreases. When the ice melts, the volume of the ice will decreases. We'll go for the second one. Decrease in pressure over ice. See, when you decrease the pressure over ice, that means the melting point increases. All these things we have learnt in concept video. Increases. Then C, increase in pressure, the boiling point of water will increase. Increases. Then D, the pressure cooker is based on principle that boiling point of water increases with the increase in pressure. With the increase in pressure. Then the boiling point of water is defined as the constant temperature at which water changes to steam. The constant temperature at which, okay, the constant temperature at which water changes to steam. Then water can be made to boil at 115 degrees Celsius by increase in pressure over its surface. If you increase the pressure of water, the boiling point will increase. That is nothing but the third question. The last question is almost similar to the third question. So answer for F question will be increasing. Okay, increasing. That's it. So these are the answers for these questions. Our next question, write the approximate value of specific latent heat of ice. See, this one we have learnt in concept video, but you can write the answer in 2 ways. I'll show both the ways. Listen, 336 joules per gram and 336,000 joules per kg. So which one you should write in exam? See, always whenever they're asking any value, okay, always go for the SI unit. This is the SI unit, this is the CGS unit. Okay, so this is the value in CGS unit, this is the value in SI unit. Always write the SI unit, so that you will get full marks. Our next question, 1 gram of ice at 0 degree Celsius melts to form 1 gram of water at 0 degree Celsius. The temperature remains same, but the ice has converted into water by melting. State whether the latent heat is absorbed or given out by ice. See, whenever melting happens, see, remember only this one, opposite of this one, melting, opposite of melting will be freezing. So remember only for melting. Okay, whenever something melts, it absorbs heat. What happens? It absorbs heat. So answer for this question is latent heat. Latent heat is absorbed by ice. So while freezing, okay, the heat will be released or rejected, but while melting, heat will be absorbed. Keep this in mind. Now we'll talk about the short questions. In that first question, a substance on heating undergoes a rise in temperature and change in phase without changing its temperature. In each case, state the change in energy of molecules of a substance. See, in this question, you need to understand what exactly they are looking for. See, while rising in temperature, what is the change of energy in the molecules happens? See, for the first sub question, whenever the temperature changes, whenever the temperature increases, the average kinetic energy also increases. See, you have to write it in full form. Then second one, while there is a change in phase, okay, assume the solid is converted into liquid, but the hint is there is no change in, without change in temperature. If the temperature is not changing, okay, is not increasing, then there will be no effect on kinetic energy. When there is a change in phase without change in temperature, average potential energy also increases. So this is the answer they are looking for. They are not asking from which state to which state it is changing. They are asking state the change in energy of the molecules. Whenever this word energy of the molecule comes, you have to talk about either kinetic energy or potential energy. Whenever you write kinetic energy, just add average kinetic energy. So average kinetic energy increases only when the temperature increases. If the temperature is constant and there is a change in phase is nothing but from one state of matter to another state. If the temperature is constant, then average potential energy increases. Keep this in mind. All these things we have learnt in concept video. Now also we are learning. Our next question, how does the average kinetic energy and average potential energy of molecules of a substance change during its change of phase at a constant temperature on heating? Whether they are heating or cooling, what is the temperature they are talking about? They are talking about the constant temperature. In previous question only we spoke, if the temperature is rising, then only kinetic energy increases. If the temperature is constant, then there will be no change in kinetic energy. The average kinetic energy doesn't change. There will be no change in average kinetic energy. Why? Because there is a constant temperature. Now we'll talk about B. When the temperature is constant but there is a change in phase. What do you mean by change in phase? From one state of matter to another state, from solid to liquid or liquid to gas, all those things, any one. Okay, whenever this happens with a constant temperature, average potential energy increases. Keep this in mind. See, to increase the average kinetic energy, temperature should increase. If that is constant, average kinetic energy will not change. Only the average potential energy will increases. Our next question, state the effect of presence of impurity on melting point of ice. Give one use of it. See, they are asking, when you add some impurity to a substance, what happens to its melting point? Whether it increases or decreases. Whenever we add impurities, the melting point, we are not talking about boiling or freezing point, all those things. The melting point decreases. The melting point decreases and we have to give one use of it. This concept is used in freezing the kulfis. you know the kulfi ice, right? So this concept is used in whenever they are adding ice, they'll put salt also, so that its melting point decreases, so it will freeze, it will keep, okay, it will be in the freeze state for a longer time. Our next question, state the effect of increase of pressure on melting point of ice. See, very simple question. If you have seen the concept video, this would have been very easy for you. See, whenever you apply a pressure on ice, okay, what happens? It will break. Once it breaks, okay, the melting point of ice will decrease, so it melts faster. That's it. So state the effect of increase of pressure on melting point will be, see, if you increase the pressure, the melting point will decrease. That's it. Our next question, how is the boiling point of water affected when some salt is added to it? So when you add some salt to your water, the boiling point will increase. The boiling point of water increases. Why it has to be done in that way? Because it makes the cooking faster. If you add salt, okay, impurities, okay, to your water, the boiling point increases. So it makes the cooking faster. That's it. Our next question, what is the effect of increase in pressure on boiling point of liquid? See, this pressure and boiling point, melting point will definitely confuse you. If you have seen the concept video, there we have explained it properly, and here also we are giving the answers. But if you have seen that video, there will be no confusion whenever I speak my answers, which is similar to the previous question. So here we are talking about pressure, boiling point, melting point. Definitely it will confuse you. So if you have seen the concept video, this would have been very easy for you. See, when the pressure increases, the boiling point also increases. That's it. Our next question, water boils at 120 degrees Celsius in pressure cooker. Explain the reason. It's a very simple question. This is what we have learned in concept video. See, we have learnt in one of the questions that if the pressure increases, boiling point also increases. That is what we are going to explain here. Listen. In the atmospheric pressure, in a normal pressure without a cooker, if you want to boil the water, the temperature will be 100 degree. 100 degrees Celsius, the water will start boiling. But inside a pressure cooker, we are not letting the steam to go out. We are not letting the steam to escape out of the pressure cooker. The vapor pressure on the water, will be nearly 1.75 times greater than the atmospheric pressure. So the pressure increases the boiling point. The increase in pressure will increases the boiling point. That's it. Our next question, it is difficult to cook vegetables on hills and mountains. Explain the reason. Very simple question. Listen, if the altitude is more, altitude means the height is more, height is nothing but the hills and mountains. On the hills and mountains, altitude will be high. If the altitude is high, then the pressure, atmospheric pressure will be low, and we have learnt already that if the pressure is more, boiling point will be more. If the pressure is less, the boiling point will be less. So here on the hill station and mountains, the pressure will be really less, okay, low. That's why the boiling point also decreases. So if the boiling point decreases, what happens? It does not provide the required heat energy for the vegetables. That's why it is very difficult to cook vegetables in hill and mountain regions. Question number 9 and 10 we have already learnt in the concept video. That is nothing but the definition of latent heat and specific latent heat. That's it. That we have learnt already in the concept video. There is no change in that. That's why we are not discussing here. Our next question, specific latent heat of fusion of ice is 336. The unit is given in terms of gram. This is very much important. If this unit is given in terms of kg, 336 joules per gram. This question they are talking about gram, correct? So we have to answer in terms of gram only. That means 1 gram of ice, 1 gram of ice at 0 degrees Celsius requires 336 joules of heat energy to convert into water at 0 degrees Celsius. At both the phase, okay, ice and water, the temperature will become 0 only. It will be constant and requires 336 joules of energy, heat energy, to convert into water. That's it. If the same question, if it is given in terms of 336, okay, any value, don't worry about the value. If they have given in terms of kg, then instead of using, in the same sentence, instead of using 1 gram of water, you have to use 1 kg of water. That's it. Our next question, which has more heat, 1 gram of ice at 0 degree Celsius or 1 gram of water at 0 degree Celsius? See, they have given 1 gram of ice and 1 gram of water, at both are at same degree Celsius, that is but 0 degree Celsius. We have to tell them which has more heat. See, always keep one thing in mind, the phase, okay, ice will always liberate heat. Whenever the water, okay, is converting into ice, water is converting into ice, it will release the heat energy. If it is releasing the heat energy, that means water has heat energy, right? So answer for this question is 1 gram of water at 0 degree has more heat energy, because 1 gram of water at 0 degree Celsius liberate means releases 80 calorie of heat to convert into ice. That's it. Our next question, which requires more heat, 1 gram of ice at 0 degree Celsius or 1 gram of water at 0 degree Celsius to rise its temperature to 10 degree Celsius? Explain your answer in part A. Okay, listen, whether it is 10 degree Celsius or 20 degree Celsius, any temperature, okay, the ice requires more energy. Ice requires more energy, because in previous question we have learnt 1 gram of water will have more heat energy. Water has already heat energy, but ice doesn't have heat energy, so it requires a lot of heat energy. So the answer for A is 1 gram of water requires more heat energy to rise its temperature to 10 degrees Celsius, and we have to explain the reason. Why? Because 1 gram of ice, okay, at 0 degrees Celsius absorbs 336 joules of energy. 1 gram of ice absorbs 336 joules of energy to convert into water. That's it. Question number 14, 15, 16, 17, 18, all these questions are give reason questions and based on the natural consequences. That is what we have learnt in the concept video in depth. So if you have seen that concept video, these questions you can aram se answer it. So instead of learning it, because the same answers we are going to learn here also, that's why we are going to skip it. Our next question, what do you understand by the change of phase of substance? See, change of phase of substance is nothing but change of state of matter from one state of matter to another state of matter. That's it. This is nothing but change of phase, and all these things happens at a constant temperature. At a constant temperature, keep this in mind. At the constant temperature is very much important. Then we'll go for the second sub question. Is there any change in temperature during the change of phase? See, we told you in the part A, okay, part A answer, we got to know there will be no change in temperature. That means, what is the answer for the second one? Is there any change in temperature during the change of phase? No, there will be no change in temperature. Then, does the substance absorb or liberate any heat during the change of phase? Obviously. Why? Because whenever, what do you mean by change in phase? That is nothing but melting, freezing, all those things. If it is melting, it absorbs heat energy. It is getting freezed, then it releases heat energy. So what is the answer for this question? Sub question C, does the substance absorb or liberate any heat energy? Yes. Next, our last sub question, what is the name given to the energy absorbed during the phase change? See, during the phase change, what is the name given to the energy absorbed or releases? See, they are asking only about energy absorbed or energy released. For both the things, the name will be latent heat. Latent heat. That's it. Our next question, a substance changes from solid state to the liquid state when heat is supplied to it. Okay, this is the statement. Now we'll go for the questions. Name the process. Whenever a solid is converting into liquid, okay, solid is converting into liquid, it is nothing but melting. So if they are talking about the temperature at which the solid is converted into liquid, that means it becomes melting point. There is no word called the temperature at which or particular temperature at which. That means they are talking only about melting. Then we'll go for B. What name is given to heat absorbed by a substance? See, we are talking about melting, okay, and the heat absorbed will be related to latent heat. So this is nothing but latent heat of melting. Okay, latent heat of melting, or we can also call it as latent heat of fusion. You can write any one of the sentence in the exam. Next, third sub question, how does the average kinetic energy of the molecules of the substance change? We know whenever there is a change in phase, the temperature is always constant. The temperature is always constant. If the temperature is constant, then there will be no change in kinetic energy. No change in average kinetic energy, as there is no change in temperature. So these are the things we have learnt in concept video. If you have seen these questions would have been very easy for you guys. Our next question is based on a graph. See, the diagram shows the change of phase of a substance on temperature time graph on heating the substance at a constant rate. So this is the given statement and this is the given graph. So first thing, whenever they have given graph, you need to understand from where it is starting. Okay, at 0 degree temperature it is starting. At 0 degree temperature it is starting. At 0 degree temperature, what will be the state of the material? It will be freezed. It will be solid. As you will take always as, you can assume it as ice only. Okay, now we can aramse assume it as ice. At 0 degree it will be in the form of solid. So whenever you see these kind of slope, AB and CD are slopes, correct? AB and CD are slopes, and BC and DE is a flat line. BC and DE is a flat line. Flat line always represents some process. The slant line tells us there is a rise in temperature. See, the slant line AB tells us, AB and CD tells us there is a rise in temperature. Okay, how much there is a rise in temperature, we'll talk about it. Whenever there is a flat line, that talks about the process. Now we'll go for the questions. Now we'll talk about the question, what do parts AB, BC, CD and DE represents? Very simple. As I told you, AB and CD represents the rise in temperature. Listen, first we'll talk about AB. Next BC, then next this is about question A, correct? Question A. After BC, this is CD, then DE. Okay, see, AB, there is a rise in temperature from 0 degree Celsius to T1. AB represents there is a rise in temperature from 0 degree Celsius to T1. Then I told you, whenever there is a flat line, okay, BC represents a flat line. Whenever there is a flat line, okay, that represents a process. Assume this as a ice only. When the ice, okay, rises the temperature, when you rise the temperature of a ice, it starts melting. So when it is freezed, and if you increase the temperature, it will first start melting. So BC represents melting of a substance. In this question they have not specified any substance, so we are assuming it as ice. You should not write it as ice. So BC represents melting of a substance at constant temperature T1. At constant temperature T1. Whenever there is a change in phase, the temperature will be constant. Keep that in mind. Then the line, okay, slope CD represents there is an increase in temperature or rise in temperature from T1 to T3, correct? From T1 to T3, that's it. Then DE again, it's a flat line. It's a flat line that represents a process. So assume it as ice. If you raise the temperature, it will start melting. If you keep on raising the temperature, the melted ice is nothing but water. What happens if you keep on increasing the temperature of water? It will start boiling. So now DE represents, boiling of substance at temperature T3, at a constant temperature T3. That's it. Then we'll go for remaining sub questions. So this is sub question A. Now we'll go for sub question B. What is the melting point of substance? So where does the ice, we assumed it as ice, right? So where does it melt? Started melting at T1. At what temperature? T1 degree Celsius. Third sub question, see what is the boiling point of the substance? Where does it start boil? That is nothing but DE. So that is at T3, at T3 degree Celsius. That's it. If you have understood the previous question properly, then this question will be little related to that. Based on that question, it is not given. But if you have known the concept where we have what do you mean by a flat line and slope line, then those things will definitely help you. See, we have given the liquid of liquid naphthalene at 90 degrees Celsius. Now we have the temperature here. Now, so this liquid, so what is the melting point? Whenever we decrease the temperature, it will come to the melting point. So whenever we decrease the temperature, it will come to the melting point. So once it reaches the melting point, we know melting is nothing but converting the liquid, okay, liquid. So it is already in the liquid form. At 90 degrees Celsius, we have brought to the 80 degrees Celsius. So here, okay, at this temperature, a process will start. We know any process means change of phase from solid to liquid, liquid to solid, anything, okay, it will happen in a constant temperature. It will happen at a constant temperature. So we had a liquid at 90 degrees Celsius at a liquid in the liquid form, then it is going to change its phase. That phase is nothing but freezing. Why freezing? Why not melting? Because we are reducing the temperature. Reducing the temperature will happen only in freezing. Now once it converted, then it will brought to the room temperature. Room temperature, that is nothing but 25 degrees Celsius. Initially it was liquid. Now it will become solid. Solid. Now they are asking, see, there is one more question. We have to mark the freezing region. We know this is the freezing point, so this will be the freezing region. This is the marking they are required. That's it. If you do this one, you will get complete marks. I know it will be little confusing, so if you get confused, again go back and watch it again. Definitely you will get the answer. Our next question, 1 kg of ice at 0 degrees Celsius is heated at constant rate and its temperature is recorded after every 30 seconds till steam is formed at 100 degrees Celsius. Draw the temperature time graph to represent the change in phases. Very simple question, but one thing you need to know is, see, when you heat an ice, okay, ice for an increase in temperature, within 30 seconds only it will convert it into liquid. So you need to make sure that this concept you already know. Okay, now listen, when you given 1 kg of ice with exactly at 30 seconds, okay, make sure it is a straight line at 30 seconds. Okay, at 30 seconds, okay, it will be converted into liquid. Once it reaches the 100 degrees Celsius, okay, this will start boiling. So if you further keep on increasing the temperature, so you're not increasing the temperature, actually it is at 100 degrees Celsius only, but as the time increases, okay, if you keep on heating at the same 100 degrees Celsius, after boiling it will be converted into steam. That's it. So this is the graph they are looking for. Make sure the lines are straight. That's it. Our next question, explain the terms boiling and boiling point. So this we have learnt in concept video, the definition, correct? That is what we are going to skip it. And we have one more sub question, how is the volume of water affected when it boils at 100 degrees Celsius? We know how temperature and density are related. I know this concept is completely different what I am telling. When the temperature increases, what happens to density? Density decreases. Where density decreases, when the density decreases, volume increases. So if the temperature increases, then volume also increases. Okay, if the temperature increases, volume also increases. Our last question, explain the following. The surrounding becomes pleasantly warm when the water in the lake starts freezing in cold countries. If the lake starts freezing in cold countries, how come the surrounding become warm? This is what we have learnt in concept video. Very simple. Listen, what happens when something is freezing, getting freezed? That means a lot amount of heat is released. So when the lake is getting freeze in the cold countries, the huge amount of heat is released to the surrounding. That's why it feels warm. Then sub question B, the heat supplied to a substance during its change of state does not cause any rise in its temperature. So whenever there is a change in phase, okay, change in state, it will not increases or decreases, there will be no change in temperature. Why? Because the latent heat of phase, is only required to change its phase. Okay, latent heat of phase. Okay, latent heat of phase means latent heat, it may be latent heat of melting, latent heat of freezing, anything that is generally written as latent heat of phase is only required to change the state or phase of a matter. So whenever there is a change in phase, that is nothing but change in state from melting to freezing, all those things, the temperature will be constant, and the main reason is the latent heat of phase requires only change in phase, not the temperature. So now we have completed all the questions, and after this one we are going to learn all the numericals. So that video will also be available in the description box. So, and one more important thing, when it comes to calorimetry, I know numericals are compared to other chapter, it is very complicated. That's why in the scope of syllabus it is mentioned only easy numericals will be asked in board exams. So if you can learn in both part A and part B, if you can learn till first 7 to 8 questions, that is completely enough to get full marks in the board exam. So first watch the concept video, then theory, then go for the numericals. You will understand everything. After all these things, we are going to solve each and every question from the board exam paper, that too in a chapter wise. Then you will understand all the logical questions, and you will be prepared for what kind of questions they will ask in board exam. Thank you.